In the variable.java file, we defined the variable value as the int or integer. This int is a data type. The data type will determine how this value is stored in memory and how Java program will operate on the value, on the variable. We already see that for the plus operator, for string data type, it's concatenation. For integer, it's a plus, it's addition. So the same operators can mean different things for different data type. And that's the meaning of data type. It determines the storage of a variable as well as the operator that you can put on the variable. You can define your own data type later in the course, but Java already have a predefined data types, actually 8 of them. They are called primitive data types. They are built into the Java language and are not derived from classes. So these types are byte, short, int, long. All these 4 are actually integers. Then we have float and double. Both are float point numbers. And we have a boolean and we have a char. Numeric data types, including these 6. The first 4 are integers, and the following 2 are floats. And you can see that you have different definitions, different storage method. For long, it will take 8 bytes to store. For integer, it takes 4 bytes to store. For float, it takes 4 bytes to store, and for double, 8 bytes. These are the primitive data types, and the operating on these data types is pretty much the arithmetic calculations. Variable declarations, when you define, you will do a data type followed by the variable name, and the data type will be 1 of the 6 or 8. Distance, timestamp, all these, right? Byte, short, int, and long are all integers. They can hold whole numbers without decimal space. Integer data types cannot hold numbers that have decimal point in them. The embedded into Java source code are called integer literals. So let's switch to this integer variable Java file. You can see I defined integer, a byte, a short, and long. These are integers. And you can have different value assigned to them, including negative values, days, minutes, miles. And when you print out a string plus a number will result in a string. Then this string will plus another string. Let's quickly run. We made a journey of 105, take 120 minutes. Account balance is -20. Hopefully you can get your money very soon, as some days of Columbus due on the spot. Okay. Floating point data types we have 2 types, float and double. And we use the same way to define a variable. Float followed by the variable name, or double followed by the variable name. When floating point numbers are embedded into Java source code, they are called floating point literals. The default type is double, which has a higher precision and a larger scope. Java is strongly typed language, meaning anything will be casted a data type. Let's switch to Eclipse, and this is how you define 3 variables, each with a value. And of course, you can also have a negative float point. The price of them, the text of the total is how you utilize these float points. So these are relatively simple. A double value is not compatible with a float variable because its size and precision. So you cannot do this. Define a variable float and then assign a float point to it. Why? Because as we said, Java is strong typed, which means this 23.5, this literal itself have a data type, and that data type by default is double. You cannot assign a double to a float because float has only 4 bytes, while double has 8 bytes. You try to put 8 bytes of double into a 4-byte float, this will cause an error. But you can force a double into a float by appending a letter F to it, like float number. This will work because you have F after it. Float and double, the difference between float and double basically is storage space. So in the old days, like 20 years ago, when memory is not as big as right now, people used to try to squeeze into as many as data into float. But these days, as we have more memory, it's not as stringent as before. So in our course, we will not use float. Instead, we will use double for all our calculations. And when you go to work and actually run into real-time projects, there should always be a guideline telling you how to choose between float and double. If you need to choose float, what's the standard way of initializing and defining? So these are the things you will consider when you run into them. For now, you need to keep in mind that float is smaller than double, and the default is double. And throughout the course, we will only use double. Literals cannot contain embedded currency symbols, commas. This is the one mistake a lot of students make. When they define variables, especially for like gross pay or salary, a lot of students will add a $sign or a comma. This is wrong. You have put that into one single literal. No $sign, no comma sign. Floating point literals can be represented in scientific notation, such as E4, because you cannot have a subscript in Java programming source code. So what you will do is using E notation. The variable plus E. The float point plus the E, and with a science notation. So there are something that you can use, you can check. And the Boolean data type is a special data type signifying it's true or false. They can have two possible values, true or false. The value of a Boolean variable may only be copied into a Boolean variable. So now we are in the Eclipse true-false statement. Boolean equals to true, and you print out the true, and Boolean equals to false. We will use Boolean once we start to do more controls on our code. For now, just remember, Boolean signifies whether something is correct or not, true or not. It is either it's true or it's false. The char data type represents one single character. Remember, this char is not string. We will talk about string later on, but for now, char is just one single literal. It can be A or Z or number 1, 2, 3, or 0 to 9, or it can be an escape sequence. Do not confuse char literal with string literals. Char literals are enclosed in single quotes. It's one character. And string literal are enclosed in double quotes and can have multiple characters. Like in this example, you see the letter equals to A and letter equals to B. Now I can also put escape sequence. For example, this is the tab. But of course, you won't be able to see the tab. So what I'm going to do is I'm going to add a pass. Oops. I'm going to add some literal so that you can see there is a tab in between. Right, you can see there's a tab in between. And one thing to note about character is how character is stored. Internally, characters are stored as numbers or like bit strings. Character data in Java is stored as Unicode character. Unicode character set consists of 65,536 individual characters, which is the 16th power of 2. This means that each character takes up 2 bytes in memory. The first 256 characters in Unicode character are compatible with ASCII character set. Now, ASCII character set should have been introduced before in your computer system introduction course. But it's very important to remember the exact order of ASCII 2. That 0 to 9 always comes before letters, and the lowercase comes after uppercase. For example, uppercase A, its ASCII code is 65. But when you store them as Unicode, the first A bit is 00, and followed by the next A bit of ASCII code 65, then followed by B, which is 0066. Characters, they are stored in memory as binary numbers or bit strings. The binary number represent these decimal values, like 00, the first, if you look at the first 8 bit, they are zeros. Then the following 8 bit, these are 65 in decimal. And the decimal values represent these characters. Again, these should be covered in previous course, but we will use them when we go into string comparison.